Hello. In this video, I'll show you how to quickly generate SDKs or software development kits, which are essentially API clients in the Rust programming language using the OpenAPI Generator system. We're building on a setup demonstrated in a recent video, which we'll link in the description if you want to follow along step by step. That said, you can apply the concepts in this video to your own SDK generation if you prefer. The idea here is simple. We want developers and engineers to interact with an API through a friendly Rust SDK. The server can actually run in any language. The fact that we have a Rust-based API on the backend is just a coincidence. It doesn't matter what backend technology you're using as long as your API is relatively clean and normally structured. Let's get started with SDK generation by opening a Cloud Shell IDE. This will be our development environment for generating the SDK. Feel free to use whatever IDE you prefer, but if you're already on Google Cloud, this is a convenient and free option to follow along exactly with what we're doing. Let's start by setting our project and creating a repository for our work. The first thing we need is an API specification, which we'll write in YAML format. If we go to the GitHub repository for the OpenAPI Generator library and check the documentation, we can see how to install this tool using npm. There are also details about setting up a YAML file. Both in the website and the repository, you'll find information not only for simple generation, but also ways to customize those SDKs. As you can see, a wide variety of languages and frameworks are supported. Today we'll focus specifically on Rust with the request library. Let's grab those installation commands so we can install this in our IDE. Now, this additional step of installing the tools as a dev dependency in your current project is good if you already have an npm project set up, but we're going to skip that and just use the generation command. We do, however, want to keep this OpenAPI tools JSON file because it specifies a specific version, which helps ensure reproducibility in our generation process. Our command will look something like this. We specify that we're using the OpenAPI Generator CLI, point to our API specification in YAML format, select our language and framework, we'll use the simple Rust option, and finally specify an output directory. Of course, we need to fill in the details of the specification YAML before running this. I won't focus too much on how to write these specifications. There's plenty of documentation available. This file might look long because we wanted a very precise specification for our API, but to put it simply, we have different paths. For example, we can get details about a specific item on our API from this path, and we have different methods against those paths like get and put for getting and updating, respectively. We also have some details at the top. For example, we need to fill in the URL where our app lives. If you haven't set this up yet, check out our previous video where we set up the CRUD API in our project and grabbed the public URL. There's plenty of metadata here too, which is helpful for documentation generation and keeping things clean. We define things like data types for our API objects as well as error codes in this specification, but that's about it. Now let's run this command and see if it works. Great! No apparent errors in the generation. If we expand the CLI, we can see that our Rust-based API client SDK has been completely generated. In the cargo.toml file, we can see what this SDK is built on. Most of these dependencies are pretty standard, with the main one being the request library, which handles our API calls. To create a simple project that will use this SDK, let's use the cargo new command to create a new project. We'll call it something like SDK example. In this example, we'll update the cargo file to import our dependency. Let's call it SDK rather than CLI. I think that's more intuitive. We'll provide a path in our dependencies, and we'll also add a couple of other dependencies, Tokio for async operations, and since our API uses UUIDs, we'll also integrate the UUID library. Now, in the main RS file is where we'll actually use the SDK. We'll keep it relatively simple while still providing a good example. Our cargo new command created a simple main function with the hello world print statement. Let's replace that with our SDK usage. We'll import a few things first. The items API module, some models for creating and updating items, and the UUID library. In our main function, we'll use Tokio for async operations by adding a decorator at the top. Our main function will produce a result that might contain an error. We'll initialize our configuration using the default settings with config new, and then set up a new item payload. Basically, we're going to use this API to create an item. If we go to the API now and access the items endpoint, we'll get an empty JSON list returned, but we want to add an item. Now we need to send that payload through the API via our SDK, so we'll define a created item variable to hold the results of that operation. If everything goes well with the API call, we'll print that result, and of course, we'll handle any error cases too. We could add more examples to test other endpoints, but let's keep things simple for now. Let's try running our code with cargo run to see if everything works. It seems there's an issue with the name, so let's fix the default name in our SDK so it can be used as a dependency. Our first attempt at drafting this code wasn't successful, but we're close. We wanted to return a result, but let's simplify that. The easiest way to return a result would be to add an OK at the end of our function. We'll also keep the UUID import in our code even though it's currently unused, as we might need it later for updates and other operations. We do need to fix the configuration though, so let's check how it's exposed in the module. Now, when we run our code, we successfully create an item and get its ID. If we check our API by listing items, we now have one example item that we created via our SDK. I'd recommend playing around with other operations like updating items, deleting them, and using the UUID library, but hopefully this gives you the right idea. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all code and the diagram file in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching till the end, and please enjoy responsibly.